இந்த வீடியோவை subscribe பண்ணுங்க, like பண்ணுங்க, share பண்ணுங்க, comment பண்ணுங்க. We are going to see the classical mechanics part 29. Here introduction is given in the first slide. Introduction is given in the first slide. Title and pages are given from 2 to 5. Basic ideas of Galileans are given in 6th slide. Galilean transformation is given in the 7th slide. Lorentz transformation is given in 8 and 9. Length contraction in 10th slide. Example for length contraction 11th. Velocity addition is given in 12th slide. Variation of mass with velocity is given in 13th slide. Kepler's laws of first, second, third are given in next slide. Square law is given in the 15th slide. Phase velocity and group velocities are given in 16th slide. Moment of inertia definition is given in 17th slide. Moment of inertia of different bodies are given from 18 to 21th slide. 23 contains moments and product of inertia. Last slide contains Eulerian angle. According to fundamental laws of physics, when the reference frames are rest or motion with the linear velocity related to one another, velocity of light in vacuum is constant. It is independent of the relative of the source and the observer. Transformation must be linear and speed is less, that is, v is less than c, they should reach the Galilean transformation. Then no particle should be greater than the velocity of light. Lorentz introduced the transformation equation related to the observation of position or space and time made by two observers in two interval of frames. Lorentz transformation or x dash is equal to x dash minus vt divided by square root of 1 minus v square by c square. Y dash is equal to y, z dash is equal to z, and t dash is equal to t minus vx divided by c square, square root of 1 minus v square by c square. This is asked in TRP question. Length contraction. Consider L0 and L are the length in rest and length in motion of an object respectively. Then the direction of motion we get L equal to L0 square root of 1 minus v square by c square. This is asked in gate question. The length of the moving object is contracted along the direction of motion by the factor square root of 1 minus v square by c square. There is no contraction along a direction perpendicular to the direction of motion. Example of length contraction. A clock will be found to run slow due to the velocity between the clock and the observer. The proper time of moving object is always smaller than the corresponding interval. Consider u and u dash are the velocities of the particle related to the system s, and s dash is moved with velocity v to s with velocity v. Here find out the values. Then the values are u equal to c. No particle can reach the speed greater than the c value. Rest mass of the particle, m is the mass of the particle in motion. We get m equal to m0 divided by 1 by root of 1 minus v square by c square. This shows that mass of the particle increases with increase in velocity. It is asked in gate question. Relation between momentum and energy is E square is equal to p square c square plus m0 square c power 4. It is asked in gate. Kepler's laws of planetary motion. First law states that orbit of the planet is elliptical. Second law states that areal velocity is constant. Third law shows that time period of the planet is directly proportional to cube of semi-major axis of ellipse. Inverse square law is asked in all type of competitive examination. When the value of E eccentricity is greater than 1 and E is greater than 0, it denotes hyperbola. Example for hyperbola is encounter between the stars. When eccentricity is equal to 1 and energy is equal to 0, it denotes the parabola. Example comets. Then E is less than 1 and capital E is less than 0, it denotes ellipse. It is Kepler's first law. Relation between phase velocities and group velocities. Phase velocity is defined as angular frequency with respect to wave vector. Then group velocity is defined as derivative value of d omega divided by dk. Then normal dispersion Vp is greater than Vg. For the abnormal dispersion Vg is greater than Vp. Then for the non-dispersal medium Vg equal to Vp. Moment of inertia, it is defined as the product of mass and the square of the perpendicular distance to the axis of rotation of the each particle in a body rotating about axis. In this topic, various objects with different positions are given below and its moment of inertia for all the positions are also given in detail. It may be asked in different competitive examinations. Here, moment of inertia for the uniform rod, rectangular lamina and circular ring, solid cone are given in detail. In this topic, moment of inertia for the circular disc, annular ring and solid cylinder are given in detail. Watch it carefully. Here, moment of inertia of hollow cylinder, solid sphere and spherical shell are explained here in the table. Watch it carefully. In this table contains moment of inertia of hollow sphere and solid cone of altitude h and base is explained in this detail. In all the tabulation, M represents mass of the body, L represents length of the body, B represents breadth of the body, R1, R2 represents inner radius and outer radius of the body, I denotes the moment of inertia, R denotes the radius of the body. Angular velocity is V equal to R cross omega. Angular momentum L is equal to I omega. I denotes the moment of inertia. Omega denotes the angular velocity. Lx is equal to Ixx omega x plus Ixy omega y plus Ixz omega s respectively. Similarly, we can derive the value of Ly and Lz explained. Then we conclude that Ixy is equal to Iyx, Iyz is equal to Izy, Izx is equal to Ixz. The three independent parameters theta, pi, psi, which would explain completely specify the orientation of rigid body, then it is called Euler angle. The Euler angle theta, pi, psi are asked in competitive exam. இந்த வீடியோவை சப்ஸ்கிரைப் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, கமெண்ட் பண்ணுங்க. Thank you.